Good morning, class. So till now I explained you what is inverse, how to find inverse using adjoint. Adjoint of a matrices also we have done, and how to find inverse, one question based on inverse also we have done. Now just see the next question. Again here we have to find the inverse of this matrix. Let this matrices be A. So we have to find the inverse of this matrices. Yeah. So this matrix, let it be A. So we first of all what we will see, I told you we will find determinant of A. If the value of determinant of A is not equal to 0, then only we'll proceed further, otherwise not. So just see determinant of A, how we'll calculate. Just see how many along this column, third column will expand. Why? Because we are having maximum number of zeros in this column. Yeah. So just see what we are having. 0 multiplied by anything 0, 0 multiplied by anything 0. Then only we are left with this number -1. So -1 lies in which row? This row and this column. Leaving this, what we are left with 1 into 3. So -1 multiplied by 1 into 3 is 3, minus 3 into 0 is 0. So you will have what? -3. Just see your determinant value is minus, yeah, this one. Now we have calculated -3 is not equal to 0. That means inverse exists. Whenever your determinant value is not equal to 0, then we can say that inverse exists. Now what we will do? Now we'll find the value of inverse. Now we'll find the value of inverse. First we will find adjoint of A. This is A. We will find what? Adjoint of A. For that, first of all, we have to find what? C11. So what will be C11? The C11. That will be equal to -1 to the power of 1 plus this 1 I plus j 1 plus 1, that is equal to 2, multiplied by, this is first element a11, leaving this column and this row, we are left with what? 3 into -1 -3 minus times 2 into 0 0. So what we are left with, -1 square is what? 1 into -3, that is equal to -3. So your a11, just see, this a11 is what? -3, or c11, whatever you call it. Then a12 will be equal to what? Let me erase it out. Let me clear it out. Okay, now a12 is what? 0. Now 0, a12 is what? 0. Clear? Now where it lies, in this particular row and in this particular column. So what will be C12? C12 will be equal to 3 into -1 -3 times 5 into 0 -0 times -1 to the power of 1 plus 2, that is equal to 3, that is equal to -1 multiplied by -3, that is equal to plus 3. Just see, this a12 value or c12 value, whatever you call it, is 3. Yeah. Same way we'll calculate a13. Now a13 is equal to what? Leaving this column and this row, we are left with what? 3 2s are 6 minus 5 3s are 15 times -1 to the power of 1 plus 3, that is equal to 4. So 6 minus 15 is what? Yes, 6 minus 15 will be 9, minus 9, and then -1 to the power of 4 is 1 only, so it will be -9. Is it clear? Just see a13 here also is coming out to be -9. This way we'll calculate all the cofactors of all the 9 elements. Yeah. We have calculated the cofactors, so we'll put the values of cofactors here. These are the cofactors. We have calculated these 3, -3, 3, -9. Same way we'll calculate others also. Now adjoint is what? We'll put the cofactors in the matrices form and then take the transpose of it. So transpose means, you all know what is transpose. This row will change to first column, second row will change to second column, third row will change to third column. Can you see this? So this way we have got the value of adjoint. Now what is inverse? Your A inverse value is equal to 1 upon determinant of A multiplied by adjoint of, yeah, this we all know. Now you have got the value of adjoint is this. The value of determinant is -3. So you have to just put the value. It will be equal to what? 1 up. Sorry. It will be equal to what? 1 upon minus 3 multiplied by the adjoint of A. Now adjoint of A is what? This one. Yeah, so we have to just put the values. If you want to multiply inside, you can multiply, or you can just put the value and yeah, just see. 1 upon in A inverse is 1 upon determinant of A into adjoint of A. A inverse value is this, adjoint value is this. You can leave till this point also, or you can multiply minus 1 by 3 to each and every element. So minus 1 by 3 minus 1 by 3 multiplied by minus 3 will give you 1. Minus 1 by 3 multiplied by 0 will be 0. Minus 1 by 3 multiplied by 0 will be 0. Then minus 1 by 3 multiplied by 3 will be minus 1. Minus 1 by 3 multiplied by minus 1 will be, sorry, minus 1 will be plus 1 by 3. Minus 1 by 3 multiplied by 0 will be 0. Same way you will multiply all the elements. Minus 1 by 3 by minus 9 multiplied by minus 9, that will be equal to what? 3. Minus 1 by 3 multiplied by minus 2, that will be plus 2 by 3. Minus 1 by 3 multiplied by 3 will be minus 1. So this way you will calculate all the values, and this will be your A inverse. Is that clear? So now you know two methods. One, finding the inverse using adjoint, or finding inverse using transformation. Yeah? Now come to the next question. Again, for this question, we will practice. You have to practice. So it's better, as I'm telling you, also do it by yourself. Yeah, you try to do it. You have seen the matrices. Let this be A. Now first step is what? Let A is equal to this. They have written let A is equal to this. Steps also you should know, because in maths, when you're giving exam, you have to write each and everything in proper steps. So let A is a matrices given by this. Then first step is what? Find the determinant of A, and determinant of A we have to find along that particular row or column where we have maximum number of zeros. It is not like that if you will take some other, if you will expand along another row or column, then answer will be different. Answer will be the same, but it will become easier for you to calculate. Yeah. So determinant of A, we can calculate along first row. They have calculated along first row. Now instead of calculating along first row, we'll calculate along this, so that you should know whether you calculate along any row or any column, expand it along any row or any column, your answer will be the same. Just you have to remember what this element is. This three element is what? A 1 3. ये ध्यान रखना है ना, because minus 1 to the power of, तो अब क्या हो जाएगा? Determinant of A क्या होगा? 3 multiplied by 3 multiplied by, leaving this column and this row, we are left with what? 4 2s are 8, minus 7, minus 7 into minus 1 is plus 7. Yeah, 8 minus 7. 3 multiplied by 8 minus 7. Then next is 0. अब A13 है, ये क्या है? A23 minus sign आएगा. A23 है तो minus sign आएगा. And then 0 multiplied by anything will be 0, so I'm not writing that only. Yeah. Then next is what? Next is yours 1 multiplied by plus 1 आएगा. Which element it is? A33. This one is what? A33. So 3 plus 3 is 6. So minus 1 to the power of 6 is 1 only. So plus 1 multiplied by, leaving this row and this column, we are left with 2 into minus 1 minus 2 minus 4 into 1 minus 4. So your answer will be equal to 3 into 8 minus 7 is 1. So 3 plus 1 times minus 6, that is equal to what? Minus. Now you can see your determinant value here also is coming out to be minus 3, and when we have calculated along the third column, then also the answer is minus 3 only. So if you expand the determinant along any row or any column, answer will be minus 3. Why I have taken this third row, third column? Because it is having a 0. You can, the answer will be the same. It's your wish. Any way you can do. I just wanted to explain you that any way you are doing it, you are going to get the same answer. Clear? So we have calculated the value of determinant. The value of determinant is what? Just keep this thing in mind, is minus 3. Now what we have to calculate for this? Now minus 3, we know that is not equal to 0. So inverse, A inverse exists. Now if A inverse exists, what we can say? We can calculate the value of A inverse, which is equal to 1 upon determinant of A times adjoint of A. Now determinant of A value we have calculated. So what we have to calculate? The value of adjoint of A. For that we have to calculate the adjoint of each and every element. ऐसा नहीं कि दो एलिमेंट का adjoint निकालना है, सारे एलिमेंट्स का adjoint आपको co-factors आपको निकालने हैं, not adjoint, सारे एलिमेंट्स का co-factors you have to find. Like if this is the first element, so your C11 will be equal to what? Minus 1 to the power of 1 plus 1, that is equal to 2, multiplied by M11. M11 क्या है? Leaving this column and this row, we are left with what? Minus 1 into 1, that will be minus 1, minus times 2 into 0 is 0. So it will be equal to minus 1 square is 1 multiplied by minus 1, that is equal to minus 1. So your C11 or A11, what they have written is minus 1. Same way, we can calculate this. Now, every time I'm calculating the first row, I'm calculating the cofactors of first column. Yeah, so that you should be clear with it, whatever row or column it is. Yeah, you have to calculate the cofactors of each and every element. ऐसा नहीं कि मैम ने 3 के बताया तो हम 3 के नहीं निकालने हैं. You have to find the cofactors of all the 9 elements. Clear? How you have to do it, that I have explained. Now suppose we are taking this element. Yeah, this, what is this element? This element A21 is equal to 4. So C21 will be equal to what? Minus 1 to the power of 2 plus 1, that is equal to 3 times M21. M21. Now M21 is what? Minus 1 to the power of 3 is what? Minus 1 times M21. Now this number 4 is lying in which row? This row and in this column. So what we are left with? This 1 into 1, 1 minus 2 into 3. So it will be equal to minus 1 times minus 5, that is equal to 5. Now just see the value of C21. Here we are having A21 is equal to 5. A21 is equal to 5. Is that clear? So this way you will calculate the cofactors of all. We'll calculate one more. C31. C31 is equal to minus 1 to the power of 3 plus 1, 4, multiplied by, leaving this row, column and this row, we are left with 1 into 0, 0, minus 1 into 3, minus 3. So this will be equal to minus 1 to the power of 4 is 1. Minus of minus 3 is what? 3. So your answer will be 3. So C31 is equal to 3. Now here they have taken A31. A31 is equal to 3. Same thing we are having. Clear? So don't get confused that they have written A31, A11 or whatever. We are writing C11. Both the things are the same. The notion can be for cofactors. You can use capital A11 also or capital C also. Yeah. So now this way you will get the value of adjoint. Yeah, this way you will get the value of adjoint. Now adjoint is what? Put all the cofactors. These 3 cofactors we have calculated, minus 1, 5, 3. Now rest of the cofactors you can calculate. They have already written. So you can check whether you are getting all these cofactors or not. If you are not getting, please check it. Very carefully do it. Because just a single minus sign also will change the answer. Yeah. So this is your adjoint, cofactors. Now transpose of the cofactor gives you what? Adjoint. So transpose we will do what? That means what? This first row will change to the first column. You can see minus 1, 4, minus 4, 1. Second row to second column. Third row to third column. Yeah. So this gives you what? Adjoint of A. So adjoint of A will be this, not this one. This is what the transpose. Transpose of the cofactors gives you the adjoint. Now we have to calculate what? Inverse. So A inverse is equal to 1 upon determinant of A into adjoint of A. Now you remember, if you remember, your determinant of A is minus 3. So we have to put the value, just have to put the value. 1 upon determinant of A is minus 3 times what? Adjoint of A. Now multiply minus 1 by 3 to each and every element inside the matrices. And you will get the value of A inverse. Clear? Now come to the next question. Just see. Now instead of what numbers, we are having trigonometric functions in this. You know, numbers are also there and trigonometric functions are also there. So don't panic. There's one and the same thing. So there is no problem in it. When you will solve it, you will get let this matrices be A. We have to again find the inverse. I have not written, so whatever questions we are doing are based on inverse only. Let this matrices be A. Then determinant of A, first step is what? Find the determinant of A. So your determinant of A, just see in the first row or in the first column we are having two zeros. So expand along either row or column. So we'll expand along the row, first row. So 1 multiplied by what we will have? 1 is lying where? In this particular first row and first column. So what we are left with? Minus cos square alpha minus sine square my cos square alpha into minus, just see, cos alpha into minus cos alpha, then minus times sine alpha into sine alpha is minus sine square alpha. Now can you take minus common? So outside we are having 1, so it will be minus 1 times sine square alpha plus cos square. So it will be what? Sine square alpha plus cos square alpha. Yeah. So it will be equal to what? You know that this identity sine square alpha plus cos square alpha is what? 1. So minus 1 times 1 will give you what? Minus 1. So your value of determinant is equal to what? Minus 1. You can see they have also calculated. It is coming out to be minus 1. Now we have calculated determinant is minus 1, which is not equal to 0. So we can say that A inverse exists. You can write this statement also. As the determinant is not equal to 0, so A inverse exists. Now we will find what? Adjoint of A. Now our next step is what? Find adjoint of A. So for finding adjoint of A, we need what? Cofactors. C11, C12, all the cofactors, Cij, all the values of Cij. So first of all, now the best thing is here maximum, just see the cofactors. You have to find all 9 cofactors. Now whichever you say from the first row, second row, or third row, or column, first column also I have explained, I have told you how to find the cofactors. Now take the second column so that you must be clear with it how to find the cofactors. This one and the same thing I'm telling you. You have to just see the element address. That's it. Now just see if I'm finding the cofactor of these 3 elements. How can I find the cofactors of these 3 elements? Just see the first element is what? A1, 2. Yeah, that means A12 is 0. So C12 will be equal to minus 1 to the power of 1 plus 2, that is equal to 3. Now where does A12 lies? In this row and in this column. So what we are left with? 0 into minus cos alpha is 0, minus 0 into sine alpha 0. So minus 1 cube is what? Minus 1. Now just see C12 we have calculated. Here they have A12. A12 is what? 0. Yeah. Now next is what? If I have to find the cofactor of this element, so this element is what? A22. A22 is what? Cos alpha. Now your C22 will be equal to what? Minus 1 to the power of 2 plus 2, that is equal to 4 times. Now leaving the row or the column, leaving the row in which cos alpha lies and leaving the column in which cos alpha lies, what we are left with? 1 into cos alpha minus 0 into 0, 0. So you are having what? Minus 1 to the power of 4 is what? 1. 1 into cos alpha is what? Cos alpha. So your C22 value or A22 value, you can see A22 value is what? Cos alpha. Wait a minute, it is coming. Wait a minute. A22 value is what? Just see, I have taken, instead of minus cos alpha, I have taken cos alpha. Just cos alpha lies in this column and in this row. Clear? Now 1 into minus cos alpha, it was there, I have taken it cos alpha, that's why we have written wrong. So C22, again I will tell you, C22 is equal to minus 1 to the power of 2 plus 2, that is equal to 4 times this 1 into minus cos alpha minus 0 into 0, that is 0. So you will have what? This will be equal to minus cos alpha. Clear? So your A22 value is minus cos alpha. Yeah. Then next is what? Sine alpha. This is what? Which element it is? A32 is equal to what? Sine alpha. Yeah. So C32 will be equal to minus 1 to the power of 3 plus 3 plus 2, that is equal to 5 times. Now, which row it is lying sin alpha? This row and this column. So what we are left with? 1 into sin alpha minus 0 into 0. Yeah. So what we are left with? C32 will be minus 1 to the power of 5 is minus 1 times sine alpha. So you will have what? Minus sine alpha. So your value of C32 will be minus sine alpha. C32 here they have written A32 is what? Minus sine alpha. Yeah. This way you will calculate the cofactors of all the 9 elements. All the 9 elements, we have calculated the cofactors of only 3 elements. It is not like that if I have calculated 3 elements, you also have to calculate 3 elements. All the cofactors we have to calculate. Clear? Now, this way you will get the value of adjoint. Clear? Now, adjoint what it is? Again and again, we are doing same type of question so that things should be clear in your mind and you will be able to do the questions. Adjoint of A is what? Put all the cofactors at the places like C11, C12, C13, C21, C22, C23, C31, C32, C33. Put all the cofactors at their places. Now, adjoint is what? Putting the cofactors at the places and taking the transpose of it will give you what? Adjoint of A. So your adjoint of A will be equal to, just see this row is changing to the first column, this row is changing to the second column, third row is changing to the third column. Yeah. Now you all know adjoint of A is this. A inverse is equal to what? 1 upon determinant of A times adjoint of A. Now just put the values. If you remember your your determinant value was minus 1. Do you remember if you have written somewhere, the determinant value was minus 1, we have calculated earlier. So what it is, put the value of determinant as minus 1 and then adjoint same place as it is. Now just see, multiply this minus 1 with each, and 1 upon minus 1 is what? Minus 1 only. So multiply minus 1 with each element. So what you're going to get? Minus 1 multiplied by minus 1, 1. Minus 1 multiplied by 0, 0. Minus 1 multiplied by 0, 0. Minus 1 multiplied by 0, 0. Minus 1 multiplied by minus cos alpha plus cos alpha. Minus 1 multiplied by minus sin alpha, sin alpha. Minus 1 multiplied by 0, 0. Minus 1 multiplied by minus sin alpha, sin alpha. Minus 1 multiplied by cos alpha, minus cos alpha. Yeah. So this way you will get the value of A inverse. This is your matrices A inverse. Yeah. Now, next we will do questions based on system of linear equations. One more question is there. This is an important one. So please just see the question. What they're saying, let A be a non-singular square matrix. If it is non-singular, that means what we can say, determinant of A is not equal to 0. So whatever they are saying, just interpret it. Non-singular matrix is there, that means determinant is not equal to 0 of order 3 into 3. Order of the matrices, that means n is equal to 3. Then adjoint, find the value of determinant of adjoint of A. Determinant of adjoint of A. If you remember, when I was telling you the properties, that time we were having determinant of adjoint of A is equal to determinant of A to the power of n minus 1. That is equal to determinant. What is the value of determinant of A? Determinant of A you can calculate. Yeah, to the power of n minus 1. Now the answer is not in the form of, we are not having any A matrices. If we are having the A matrices, if they have given some matrices A, then we can calculate the value of A, and a determinant we can calculate, and then we can calculate. I told you 1 mark question comes. Yeah, if we have the value of determinant, suppose A is given as some matrices 2, 3, 4, 0, 1, 2, 4, 5, 6, but they have not given. If they have given this matrices as A, then definitely we can calculate the determinant and then put the value n. N is 3, so n minus 1, that is equal to n is what? 3, 3 minus 1, 2. So first calculate the value of determinant, whatever value, suppose it is coming out to be 4 or 5 or 6, so 6 square 36, whatever value it comes. I don't know what, we have not calculated the determinant right now. One method is this, but here what we are having, here we are not having the value of determinant. We are not, we are not having the matrices in it. Just we have to give the answer. We have to choose the answer from all these three things. Clear? So how we can do this? Just see, A is a non-singular square matrix of order 3. So if it is a non-singular matrix of order 3, we know that adjoint of A into A is determinant of A into A. That this thing we have proved. If you remember, it was the first question that adjoint of A into A is equal to A into adjoint of A is equal to determinant of A times In, where N is the order of matrix A. Whatever the order of matrix A will be there, that will be the only the order of this identity matrices. Clear? तो ये हमने प्रूव किया था, तो इसको हम यूज करेंगे, है ना, एक क्वेश्चन में. इफ यू रिमेंबर, जस्ट गो बैक इफ यू डोंट रिमेंबर. So adjoint of A into A is equal to determinant of A into I. Clear? Is that clear? So we have to find the value of adjoint of A if A is a non-singular matrix. So what we have written, adjoint of A into A is determinant of A into I. We know that what is determinant of A? Determinant of A multiplied by I, and we write this way, determinant outside and the value of I, identity matrix of, as it is written, the order of matrix is 3 into 3. So the identity matrix will also be of order 3 into 3. Clear? So determinant of A multiplied by the identity matrices. Now, if you know that determinant is what? Determinant is a value. So if whatever value it is, can we multiply determinant with each and every element? Yes, we can multiply. So what we are going to get? We can multiply the value of determinant with each and every element of the matrices. So when we will multiply, what we are going to get? Determinant of A into 1, determinant of A. Determinant of A into 0, 0. Yeah. Same way, determinant of A into 0, 0. Determinant of A into 0, 0. Determinant of A into 1, determinant of A. Determinant of A into 0, 0. Determinant of A into 0, 0. Determinant of A into 0, 0. Determinant of A into 1, 1 determinant of A. Yeah. So this way we will get the value of determinant of A multiplied by I will be this value, obviously. Yeah. हम आइडेंटिटी मैट्रिक्स के साथ कोई भी एलिमेंट को मल्टीप्लाई करते हैं तो हमें क्या मिलता है? इस तरह की मैट्रिक्स मिलती है. Now just see, adjoint of determinant of adjoint of A into A का determinant क्या हो जाएगा? ये जो वैल्यू है ये इसके बराबर है, determinant of A into I के बराबर. क्लियर? तो हम लिख सकते हैं adjoint determinant of adjoint of A into A will be equal to the determinant of everything. क्लियर? ये मैट्रिसेस है ना, यहाँ पे सिंबल पे ध्यान दो. ये देखो इधर, यहाँ ये एक मैट्रिसेस थी, हमने इसको किस में चेंज कर दिया? डिटर्मिनेंट में, है ना. तो आप बोलोगे मैम डिटर्मिनेंट का लिया, डिटर्मिनेंट ही तो लिया है, मैट्रिस हैज चेंज्ड इनटू दिस डिटर्मिनेंट. क्लियर? सो इन दिस इक्वेशन व्हाट वी आर डूइंग, वी आर टेकिंग डिटर्मिनेंट ऑन बोथ द साइड. अगर हम दोनों तरफ डिटर्मिनेंट लेते हैं तो हमारा क्या आ जाएगा? एडजॉइंट ऑफ ए मल्टीप्लाइड बाय ए, है ना, एडजॉइंट ऑफ ए multiplied by a का whole determinant is equal to determinant of a का भी whole determinant. तो determinant of a into I की वैल्यू अगर ये है तो इसका whole determinant क्या है? ये तो matrices है. whole determinant क्या हो जाएगा? determinant of a 0 0 0 determinant of a 0 0 0 determinant of, yeah, यही लिखा है उन्होंने और कुछ नहीं. So your adjoint of a into a determinant is equal to this value. Now just see, determinant of adjoint into A is equal to what? अब आप अगर determinant की properties पढ़ो, matrices की properties are different than determinant. From this first row, can we take determinant of A common? We have taken common. Now from the second row again we can take determinant of A common. From the third row again we can take determinant of A common. And then what we are left with? If we have taken one common from the first row, we are left with 1 0 0. Yeah. Second row, if we have taken determinant common, we are left with 0 1 0. Then if from the third row we have taken determinant common, we are having 0 0 1. This is what? Identity matrices. Clear? So it will be equal to what? Determinant of A to the power of 3 is equal to what? Determinant of adjoint of A multiplied by A, है ना. अब हमने एक और प्रॉपर्टी पढ़ी थी, हमने क्या पढ़ी थी? डिटर्मिनेंट ऑफ ए बी इफ देयर आर टू मैट्रिसेस इज इक्वल टू determinant of A multiplied by determinant of B. Clear? So this adjoint of A into A can also be written as adjoint of A determinant of adjoint of A into determinant of A, which is equal to what value? This AQ, which is equal to determinant of AQ. Yeah, so 1A will cancel with this A. So you will get here what? Square. Yeah, 1A will be cancelled here from LHS and RHS. So determinant of adjoint of A is equal to determinant of adjoint of A is equal to determinant of A whole square. Yeah, that only they have proved. Just see it. Determinant of adjoint of A into A is equal to what? A cube into I. A cube into determinant of I will be what? Identity matrix will be what? I only. So A cube. Now adjoint of A into, just see the property. Adjoint of A into A whole determinant is equal to what? Adjoint of A determinant into A determinant, which is equal to what? Determinant of A cube. So the correct option is what? This one. Yeah, A cube. So one A determinant will be cancelled with this determinant here. This determinant will be cancelled with one determinant here, and we will get the value of this as A square. Yeah. So this was an important question. It's time now actually. So we'll continue in the next class. Some more questions are there that we will do. Yeah. Till now we have done exercise. Almost all the exercises we have done. Now you can do each and every exercise of this chapter. So please do all the exercises, because only the last exercise is left based on solving the equation using inverse. That also I've explained. The method I've explained, whether the equation is consistent or not, inconsistent, consistent, that I've explained. But only questions we have not done. The questions we will do in the next class. By the time, till inverse, whatever questions are there till inverse, please solve them. Clear? Maybe exercise 3.5 till 3.5 you can finish it up. Please do questions. Please practice it, because maths need practice. Okay. So complete your work, chapter 3, chapter 4 also till exercise 3.5. And if you have any problem, you can ask. Okay. Thank you, class.